Hello everybody and welcome to this video which will be about crude oil and fuels and specifically about hydrocarbons. Now, crude oil is an extremely valuable commodity in the 21st century. Some of the derivatives of crude oil are used to heat up our homes, for example, and are used as fuels in our cars, trains and planes. So what is crude oil actually made up out of? Well, it is a mixture, of compounds called hydrocarbons. In other words, crude oil is made up out of lots and lots of different hydrocarbons mixed together. Now, these hydrocarbons, they aren't chemically combined together, they are just physically mixed, and that means that they can be separated. And we'll talk about separation of crude oil later on. So, first of all, let's just look at this word hydrocarbons. So, hydrocarbons are made out of two elements. The first one, as we can see here, is hydrogen, and the other one, as you can see, is carbon. So any hydrocarbon will contain only these two elements. Now, there is a very, very specific way in which we name our hydrocarbons. To begin with, we're going to look at the homologous series of alkanes. So we're just going to look at alkanes first of all. So, alkanes are hydrocarbons, where there are only single bonds between the carbon atoms. The very, very most simple alkane has the formula CH4. And we can draw out CH4 as so. Carbon in the middle and then 4 hydrogens around it. We need to remember that carbon always makes 4 bonds, right? This particular alkane, has the name methane. Because it has 1 carbon atom, it is called methane. Now, as we go on in the homologous series, we move on to the next alkane. The next alkane has 2 carbon atoms. So it's got the formula C2. So I'll draw out my C2 first of all. Remember what I said, all the alkanes have a single carbon-carbon bond. And remember that all of the carbons must make 4 bonds. So, remember this is a hydrocarbon, so everything must either be carbon or hydrogen. So I'm going to fill this in with my hydrogens, like so. And then we can complete the formula of our hydrocarbon. So it's going to be C2 and it's going to be H6. Alright, just to finish it off like that. Now, because it's got 2 carbon atoms, we call this one ethane. And now we can move on in our homologous series and talk about the next one. Now, the next alkane in our homologous series will have 3 carbon atoms. So we can begin by writing the formula out. It's going to be called C3. So I'm going to write my chain of carbon atoms first of all. Remember, these are alkanes, so again, just single bonds between the 3 carbon atoms. And then the rest of the bonds made by each carbon, will be populated and in fact saturated by hydrogens. So C3H8. Now, when you've got a alkane which has 3 carbon atoms, we call that propane. Now, in GCSE we need to know up to the 4th in the homologous series of alkanes. So the next one will begin with 4 carbon atoms, which I'll draw down here. 1, 2, 3, 4. Remember, I'm only drawing single bonds between the carbon atoms. And then I'm saturating the rest of this molecule with hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore the formula is C4H10. Now, because this has got 4 carbon atoms, this has got the name butane. So we need to know the first 4 alkanes in the homologous series. We need to know what their names are, what their formula are, and what their structures are. Now, there's an easy way to remember how to write the formula of an alkane. Okay? Each alkane has the same general formula, which we can write like this. It will be CnH2n plus 2. Okay? Where N simply represents the number of carbon atoms. Okay? So, for example, if I have C2 and I want to work out the number of hydrogens that are around it, then I simply put my 2 and substitute it in here instead of the N. So I've got H2 times by 2, which is 4, plus 2, which equals 6. So it would be C2H6. Another example, let's say that I've got 8 carbons in my alkane and I want to work out the number of hydrogens. Well, now N is equal to 8. So if I apply my 2N plus 2 formula, so 2 times N and N equals 8, so 2 times 8 is equal to 16, plus 2 is equal to 18. So we'll have the formula C8H18. Okay? And that's how we work out the formula of an alkane. In the next lesson, we will begin to look at how crude oils are separated using a process called fractional distillation. I hope you can join me then.